Okay, class, so let's take a look at a different problem. And this one says a particle moves along the y-axis according to the position y of t is equal to that function, where t is in seconds. Now, the first part says at what time is a particle at rest? Well, before I do anything, let's actually find these derivatives. So right now, I have the position, right? So I know position is this. What I need to do is find the velocity. So velocity is a derivative of the position. So I take this derivative right here and I get 6t squared minus 42t plus 60. Good. That's a 42 right here. And I also know the acceleration is a derivative of velocity. So that's going to equal 12t minus 42. In case we need those. So I'm going to take a look and say, okay, I need to know when a particle is at rest, right? So if I go back to our little chart, anytime I see that a particle is at rest, let's take a look at these. Do I see rest in here? No. Do I see rest in here? Yes. It says is at rest. That means make my velocity equal to 0. So let's go back to our problem. And I'm going to make the velocity equal to 0. So I'm going to take my green equation right here and set that equal to 0. So I'm going to get 6t squared minus 42t plus 60 equal to 0. Well, one of the fastest ways to do this is to factor, so I'm going to pull out a 6. I'm going to get t squared minus 7t plus 10 is equal to 0. And if I do some of my math, what I'm going to get is 6 times t minus 5 times t minus 2 is equal to 0. And that's going to be my little terms. So I can see that it is possible to get more than one time. So if I continue to solve this, I'm going to get t minus 5 is equal to 0, or t minus 2 is equal to 0. 2. So if I solve this, I get the time is equal to 5, and it's, according to the problem, time is in seconds right here. So one of my answers is 5 seconds. Let's do SEC. Or t is equal to 2 seconds. So there are 2 times where the particle is not moving. It's at time equals 5 and time equals 2. Good. So let's do this. Let's go ahead and copy these problems right here. Oops. Take a look. Let's do this. Copy, just so we have it on the other side. But part B says, well, I'm going to paste this here just so we have an idea of what our velocity and our acceleration is. Let's group them. Let's make it smaller. Sorry for the messy writing. Part B says, is a particle moving up, down, or neither at t equals 1? Give a reason for your answer. So once again, let's take a look at our chart right here. Now I want to look for the words up or down. So do I see up or down on here? No. Do I see up or down on here? Exactly. There's an up right here or a down right here. So I need to find out, is the velocity positive or is the velocity negative? So let's go back to that problem. And once again, I'm going to use the velocity equation. And if I use the velocity equations, now I want to actually plug in 1. So I'm going to get v of 1 is equal to 6 times 1 squared, which is 1, minus 42 times 1, plus 60. So I get 6 minus 42 plus 60, and that gives me negative 36 plus 60, which is equal to 24 feet per second. So am I going up, down, or neither? Well, if I take a look at my answer is positive. So what I'm going to say is, since v of 1, let's actually type this because I think my typing might be clearer than my writing. But what we can say is, since v of 1 is greater than 0, or you can say is positive, the particle is moving up. Good. So this is the work to show me that the particle is moving up. Good. Let's continue. Part C says, what's the particle's average velocity over the interval 0, 3? So let's take a look at our equations again. And I want to find average velocity. So under here, I don't have an average velocity. Here I have velocity, but is it an average velocity? No. And here I have acceleration, so I know it's not that either. It's not here, but I do see I have an average velocity right here, and I even have the symbols of times in brackets. So let's go back into this equation and see how we can solve this. So I need to find the average velocity at 0 and 3. So the general equation is the velocity average is equal to s of t2 minus s of t1 divided by t2 minus t1. And like I said, in this case, we're using y's for position, so I'm going to change this to a y and this to a y. If I plug in, 0 is my t1, 3 is my t2, so I'm actually going to see what I get when these are plugged in. So, let me continue with my pen. Average velocity is equal to y of 3 minus y of 0 divided by 3 minus 0. Well, since I'm looking at y's, which equation should I plug into? Good, the y equation. So if I do the work, let's do this right here. Y of 3, if you plug in 3, go ahead and try this work on your own, but if you plug in 3, you're going to get 48. If I plug in 0, if you take a look at the equation, this cancels, and this cancels, and I'm going to get a 3. So this is equal to 3. So if I plug it in here, I get 48 minus 3 divided by 3 gives me 45 divided by 3. 45 divided by 3, which equals 15. If I take a look, I don't have any units for the particle. All I know is time. So we're going to say 15 units per second. Okay. Good. Let's do part D. Part D says, what's the average acceleration? So this is very similar to our previous problem, except in our little chart, average acceleration uses V's instead of S's. So let's go back to our problem. What I'm actually going to do is I want to copy and paste this equation so they help us out a little bit. Copy. And then on part D, right here, let's move it over. So average acceleration is the following equation. Acceleration average is equal to V of t2, which is 3, minus V of t1, which is 0, divided by 3 minus 0. If I plug in 3 into the top value, what I'm going to get is negative 12. So v of 3 equals negative 12. If you plug in zeros, you notice that your t's are going to cancel, so v of 0 is going to leave me with 60. So if I plug this in, I get negative 12 minus 60 divided by 3 gives me negative 72 divided by 3, which gives me negative 24 units per second squared. So that's our answer for part D. Part E is down below, and it says, actually, let's do the equations again just so you guys can see. So here are my equations again. And it says, find the speed of the particle, so I know this is important, when the acceleration equals 6. So what am I looking for here? Number 1, I need to end with a speed. And we know speed is the same as, speed is equal to the absolute value of v of t. So I am going to need this v of t equation that is up here. I'm going to use that later. But I actually need this information because in order to use my v of t, don't I need to have a t? So I need to find out what this t is by using this piece. It says set the acceleration equal to 6. So if I were to type that out, that means I need the acceleration, which is a of t, equals is the equal sign 6. So where am I going to find this a of t? Well, don't I have it in this blue equation? So what we're going to end up doing is solving this algebraically. And what I get is 6 is equal to 12t minus 42. If I add 42, I get 48 equals 12t. If I divide by 12, t is equal to 4 seconds. So let me erase that. Is equal to 4 seconds. So what do you think I'm going to plug into my velocity equation? Good, a 4. So if I do that, I'm going to do the absolute value of 6 times 4, so 6 times 4 squared is 16, minus 42 times 4 plus 60, absolute value that. So what I'm going to get, if I do my math, is a negative 12 in absolute value, which gives me 12. And I'm going to have units per second. Good, so by taking a look at the different phrases and taking a look at our word problem chart, gives us an idea of where to go. So what I'd like you to do is go ahead and try the next one on your own. It says determine the time when instantaneous velocity equals the average velocity. So see which equation you use for velocity, see what you use for average velocity for this, and then continue on with our chart. Okay, so good luck with that, and then let me know if you need any help. So please come in if you have questions. We'll be continuing to review this during class. Thank you.